Thanks for joining today's webinar, AI-powered visual inspection, how XBuild cut construction bid time by 50%. Joined by Rob Moran, co-founder and CTO at XBuild, and Quinn Kilo, visual AI specialist at LandingAI. With that, I'll hand mic over to Quinn.
Great. Thank you, Grace, and welcome everyone. So as Grace said, we're going to be talking a little bit about how XBuild has used visual AI to automate some of their processes in the construction bid process. LandingAI, have been working with XBuild for the last couple of years, and we're excited to share some of the work that we've been doing together. So as part of this presentation today, I'll go over the agenda really quickly. We're going to do some quick introductions on both ourselves and our companies. Rob will give a little bit of background on the challenges in the construction documentation space. We'll talk about the solution that was actually used to automate the process that we're talking about, how it was implemented, the results that we achieved, and then finally, we'll talk about some of the future directions and conclusions for the presentation. And time permitting, we'll open it up for question and answer at the end. So please feel free to drop your questions in as we're going through the presentation. We'd love to answer them at the end. All right. Rob, you want to introduce yourself first?
Yes. Hi, I'm Rob, co-founder and CTO at XBuild. We've been working on this XBuild product now for a couple of years. I guess in the next slide, I'll get a little bit more into what XBuild itself does. But essentially, we are a platform that enables construction companies to get their pre-construction bidding done in under a day. And in fact, in many times under an hour or two, which is a major disruption to what the current status quo is. So I'll get more into that, but hi, and nice to meet you all.
Great. Thanks, Rob. And to introduce myself, so I'm Quinn Kilo. I'm a vision specialist with LandingAI on the go-to-market team. I've been with the company for the last 5.5 years. Background is in the manufacturing space, but have spent the last kind of basically half of my career on automating visual inspections and working with customers across various industries to do that. So yeah, excited today to share a little bit more about this project. And yeah, let's quickly introduce LandingAI. So as a company, we're focused on democratizing visual AI technologies through our state-of-the-art software platforms. So the one that we'll be talking about today is called LandingLens. So LandingLens is a platform that developers can use to build, deploy, and manage visual AI solutions. And what do we mean by that? That really means using AI to analyze any sort of visual data, whether it be images or videos. If you're trying to get some sort of insights or analyze those images, our platform can help you build a solution to do that without needing to be a machine learning expert. So we're really trying to lower the barriers to entry and also enable scaling of these enterprise-grade solutions. We work across a number of industries, from manufacturing to utilities to insurance and life sciences and retail. The use cases vary quite substantially, but again, if there's vision data associated, we're pretty well suited to solve those applications. I will mention briefly at the end of this presentation our other technology or other kind of forefront that we're working on, which is agentic AI centered around vision. So that's kind of more in the generative space, but we'll talk a little bit more about that later and why we think it's going to be impactful for especially folks in the construction and industries like XBuild. But yeah, with that, maybe we can go to the next slide.
Cool. So getting into what XBuild does, I guess, in a bit more detail. So let's say that you're a roofing company that does like insurance claims, so like hail damage, wind damage. So typically what will happen is the homeowner will call you up and you'll go to their property and you'll take a bunch of photos. Typically, that could either be with a drone, if it's a high roof or a high steep roof, or just most of the time just you climb up on a ladder, take a bunch of photos by hand with your iPhone or whatever. You typically take somewhere between 25 to 100, maybe even upwards of 200 photos if there's just a lot to take. But what you're looking for is stuff like, I want to identify all the different components on the roof. I want to see what damages there are, because ultimately that all is going to be used to generate a project scope, or an estimate, depending on what terminology people use. And building that without XBuild, just in the status quo, typically what happens is this takes days. People have to, if you're a construction firm, these are small to medium-sized businesses, they either have to outsource their estimating to some other human firm, or they have to just hire one or more estimators in-house that just work centrally, because also estimating as a process isn't something that all the people at a roofing company, all the sales reps understand how to do. In this GIF, it's kind of flashing through some of the things that we output in our XBuild report. We actually just passed it, but one of the earlier things that it shows actually is all these line items of the scope itself. So what we're able to do is then use the site photography, look at the location of the building and look up localized building codes, get some semi-structured information from the contractor about what they actually are trying to accomplish. And then we're able to automatically generate the scope. You'll actually see the scope in a second. So this here, those line items, so all these different line items and quantities get plugged into, and we have a system that can use the software that estimators use, which is called Xactimate. There's Xactimate, Symbility, and some others, but what we're able to do is use that software and deliver instantly, what they would typically, again, take days to do. So yeah, that's essentially what XBuild does, and computer vision is obviously a pretty big part of that, because unless we want the contractor to go through and tell us all of the details, instead it's a lot easier for them to take photos, then we can pull out the details that then again affect what gets into that estimate. So we can go to the next slide. So as you can see in that previous GIF, like just sliding through some of the pages of the document that we ultimately give the contractor, site photography is super important for that. There's, as I said, 25 to 100, sometimes more photos that go into it. And before we introduced computer vision, we had a team of people that was literally going through all the photos and having to recognize all the different components, all the damage that we're seeing, and then kind of we would wrap that together into more like a master list of items that would go into the scope generation process. That would typically take 3 to 6 hours per, just because of how much information there was to look at and to label. It's obviously also pretty error prone, and it's also extremely difficult for us to scale as a software company that's now nationwide. We have contractors across the whole nation, so that's not scalable at all. So obviously that slows down kind of our project delivery times. It increases our costs and the amount that we have to redo from errors, and it's difficult to scale essentially. You can also see at the bottom there's a couple images that just show. We'll show some more in detail with Quinn as he walks through the project, but you can kind of see the level of like kind of photos that we have to look at. So you can go to the next slide. And yeah, this is a nice screenshot as well of kind of one of the models that we've built using LandingAI. So by using LandingLens, we're able to automate the detection of components of the roof and what we did is we defined, like on our own, we defined a library of roof components and like roofing components, siding components, other exterior components, yard features, because right now our target market is roofing and exterior contractors. We're going to be expanding into additional verticals this year, but currently that's our target market. So we have this library. Like this particular screenshot is showing the training set for our vents detector. So there's a bunch of different types of roof vents, probably like a dozen or so different types of roof vents that we're looking at, and those all become different specific line items that could exist. There's actually, in that Xactimate software that I mentioned, that's the main output, there's 14,000 line items. I'd say about 700 to 1,000 of those are relevant for roofing, but still it really matters exactly what type of vent. Not only, okay, is this a box vent versus a pipe vent, but if it's a pipe vent, is it a lead pipe vent or is it a PVC pipe vent? Or if it's a box vent, is it metal or plastic? Because these all, again, affect the line items. So we've done is we've built a set of computer vision agents trained in and hosted in Landing Lens so that we can get these images that people submit labeled very fast. And yeah, I think next slide.
Perfect. Yeah, thank you for the context there, Rob. I think that's a really cool application, and it's just one of many that they're doing in LandingLens. I think it's helpful to maybe step back and talk a little bit about how the LandingLens workflow is structured. And I'll actually show a quick demonstration on the project that Rob was just referring to, so we can get a little more concrete with it. But the platform is structured in essentially three major project phases. So there's data management, model training, and deployment management. So this really represents the full life cycle of a visual AI application, or really any AI application. And LandingLens is this full end-to-end flow. So data management is really the concept of curating your data set for model training. So the ability to ingest data, label that data, and get it ready for model training. Model training in LandingLens is we make it as simple as possible. So it's just the click of a button. You click a train button, and it takes the data set that you labeled and automatically trains a model. And once the model is trained, you'll get a performance report that gives you your metrics based on a test data set. We'll see this in a second. And from there, you can decide to either keep iterating on your model to get better performance, or let's say your performance is good enough, you can move on to the deployment phase, which is essentially taking this model that was trained and running it in a production scenario. So for deployment, we have flexibility there. We can either deploy these models to physical edge devices through either our Landing Edge software or our Docker container option. So customers can download models off of LandingLens and run them essentially wherever they want. But the other option is running through a cloud endpoint. And we make this very seamless in LandingLens as well, where we can just click deploy and it automatically spins up a cloud endpoint. And from there, the model will be hosted in the cloud, and then you can just over API send images and get predictions back. And this is actually the process that XBuild is following today, is this cloud inference endpoint. I think one thing to point out here is that's really not the end here. These projects are cyclical. So once you're deployed, there's mechanisms to actually send production images back to your training environment. So let's say you're running that vent detector for that particular use case. You capture a bunch of images in a production. Let's say there's a new category that comes up that you want to be able to classify. You could pull those images seamlessly into your training environment, add them to your data set, and retrain the model, redeploy that model. So the fact that this whole platform is tied together, it allows for this kind of continuous learning lifecycle that's super important for AI applications and use cases. With that, I think the next slide is going to the demo, so we can actually show how that all works. So let me go ahead and share my screen. So here you will see the user interface for LandingLens. We're actually in the XBuild org here, so you can see some of the projects that are being worked on. So in this page, you're going to see all the different projects, which are essentially associated with different models for different tasks that are being done within LandingLens. We can create a new project if we want. And from here, we can decide what type of projects we want to run. The project that you pick depends on what you're trying to get out of the images. In this case, we're trying to localize things within the image, i.e. the vents. So we would be doing an object detection project. And here I'll just quickly walk through what it looks like to add some data. So I'm going to drag in a folder that I have. Maybe if I, okay, well, my mouse doesn't seem to be working. So I'm going to go ahead and go to a project that was already created here. So essentially, I had uploaded a bunch of images, just a subset of the actual data set that was used to train the real production model. And when you upload the images, it will pull in, if you have them already labeled, it can label them automatically. If they're not labeled, you can come in and do the labeling process yourself. So for example, drawing these bounding boxes over the vents, et cetera. And don't worry, Rob, this is a new project, so I'm not messing with your production projects here. But once we have labeled data in here, we can see kind of our distribution of our different categories. So in this case, it was just a small subset that I grabbed, so we don't have really good representation of the different categories here. So we probably shouldn't expect really great performance out of the model. But nonetheless, once we have labeled data, at least 10 images, we can actually go ahead and train the model with this train button up here. And what that will do is it's going to go find a compute resource in the cloud. It'll kick off the training job, and then you can kind of monitor the training process as it goes through. So in a second here, you'll see this loss chart start to populate, which essentially tracks the model's learning over the process. So what you want to see is this kind of downward curve that indicates the error is dropping as the model learns the use case that it's trying to learn. So generally, this for a data set this size will take about a minute or so, so pretty quick. And once it's finished, we would get a performance report like we're seeing here. So this is a model I trained earlier today. And we get some high-level metrics, but we can also go to our models page and dig a little deeper on these trained models. So for example, I can see a confusion matrix to see how well the model is categorizing each of these different classes and where it might be getting confused. So we can see here there was one image where it should have been called, well, there shouldn't have been any labels, and or there's one bounding box where there shouldn't be a label, and the model predicted a ridge vent. So we could go in and see an example of that here, and we can see the erroneous bounding box that was put here. And we actually see a confidence score associated with it as well. So that's actually, this is out of 1, so 0.29 is actually a pretty low confidence, and that's actually a good sign. It means the model wasn't very confident in this prediction that was actually wrong, right? So this is something that could be improved with further model training or further data additions to the model. So that's kind of how the training process works. You kind of iteratively go through, train the models, analyze where you might be having misses or confusions within the model. But let's say we have a model trained that we think is good to go and we want to deploy it. We could take that model from this models page and click the deploy button and then create a cloud endpoint to deploy it. Now, I'm not going to do that here. I'm just going to hop over to the actual project that this was based off of. And we can take a look at kind of the deployment page here. So here we can see there's actually a much bigger data set here. We have over 1,000 images and much better representation and a nice, much more level distribution across the different categories, right? So here we can come over to our models page. We can see there's a bunch of different models that were trained, a bunch of different configurations that were tested to try to get the best performance. And then we can come over to our deployment page, and this is actually where we can monitor the production deployments. And so this model is running in the cloud. Those images are being sent from XBuild to the endpoint, and then predictions are being created on those images, and those will all populate here. So I'm on hotel Wi-Fi here, so it's loading a little bit slow today, but here you can see some of them populating here. But what's nice here is you can go through, you can find either like low confidence predictions or potentially new classes of categories that maybe you want to pull into your model, and you can add them back to your project or back to your model building page to then retrain a version 2, version 3, et cetera, and redeploy and follow that kind of virtuous cycle. So hopefully that gives a nice sense of how the workflow works in LandingLens. With that, I'm going to turn it back to Grace to share the slides.
Cool. So yeah. So what we started to do then is say, okay, like what are all the different components that we need? We broke them up, as you saw, like vents detector, that's a single detector for vents, not like all the possible things. There's other detectors as well. So we had to kind of define, okay, like what are the different detectors that we're going to need? We kind of used a process of being reasonable about chunking them up to where each detector would maybe spit out like no more than 10 or so different items, that it wasn't too segmented. So there was a bit of kind of R&D kind of finding what worked best in that. But once we did that and we figured out, okay, what are the different detectors that we need for roof and for exterior and for interior, exterior meaning siding, and yard features. So then we trained the models. As you may have noticed in there, with landing, it makes it really easy to not even need that much. Like for the vents detector, we have low thousands of trained images. So we were able to do that. you can even get it going with less, but to make it, more accurate. And there's a lot of subtlety between these vents. It's not like it's like a dog and a car. It's like some pretty subtlety. So that's why we added thousands. But then anyways, we deploy those models, and then as you can kind of see here, this is just a small screenshot of part of the user application, the web application. But yeah, so in this case, there's 40 photos, and just as soon as they enter them, then we start labeling them. So it starts to go down from 40, and I just screenshot it for a couple seconds, so it gets down to 20. But yeah, it's just going through and labeling everything. So we basically make the inferences to the API. And then as we get the labels back, then we just under the hood, like store the labels in the image files, basically, in our database. So yeah, I mean, this super, as I mentioned before, this took us from about 3+ hours down to like 30 minutes on the human side of, like, we still have human data labelers that are used for verification. So in particular, when we get low confidence images back, like you saw in one of Quinn's examples there. But either way, since everything's already labeled, they're not starting from scratch. We do intend to get to a point where we're just bypassing everything, or at least like 90%, so that we can get that down from 30 minutes even down to like 5 or 10. But yeah, that's kind of where we're at right now. And yeah, I think I mentioned, so I kind of already talked about this, I guess, in the last slide, but yeah, so customer uploads images into the application. It's a web application. We don't have a mobile application, but they upload images, or we scrape them from one of their other image sources, which I don't need to get into. But and then we basically have a listener to where as soon as images hit our platform, we automatically like put them in a queue so that we can start asking Landing to start labeling them. We get those images back. And then as soon as all the image labeling is complete for a particular project, then we move on to the next step of, okay, having humans verify that the labels are correct. And once that happens, then we send the kind of a summary of the image labels, as well as all the other things I mentioned. So building codes, if there's existing documentation, we send all of that into our scope generation system, which then spits out that final Xactimate scope, as well as the bigger XBuild. We call it an XBuild inspection report PDF. Yeah, so that's the next slide. So as I've mentioned, 84% faster solution, that's going from 3 hours to 30 minutes, 90% plus classification accuracy. So like we still do have, I think even in that particular thing that Quinn showed, I actually noticed one error, but which happens. And I think in that case, in that particular one, it was actually really interesting because one of the first things that we do is we send a first call to the image and say, hey, is this the roof? Is it the exterior? Is it the interior? And then that'll help us narrow down and then call only the specific classifiers or detectors that we need. And there was this really, again, this was a few minutes ago, but there was like this shot that showed a very up close, like I think what it was like someone peeling back shingles and looking underneath at the decking. And that's it was a really weird shot. So we thought it was roof, and therefore it called the vents detector, and it thought that a nail was a pipe vent, right? So that still happens because it actually kind of does from a distance look like the shape of a pipe vent, which is pretty interesting. So we still have humans that correct those errors, but those are quite rare at this point. And it also just allows us to scale. So we're doing 3 million inferences right now annually. But we're a startup, we're scaling a lot, so that's only going to increase dramatically over the coming years. So faster project turnaround time, lower errors. It's essentially the TLDR of the impact. Yeah, and what I think I've mentioned, kind of where are we heading? On the computer vision side to start, the biggest thing for us is to say let's make our models, first of all, even more granular so that we can understand and we're going to need to label a lot more data, but so to where we can really understand all these even better subtle differences, even like that error that we saw here, like being able to not have those types of errors, and to also expand more into the interior think right now on the interior side and even on some of the siding, we kind of have a bit of a limited library that has nothing to do with landing. That's literally just us and the time that it's kind of our roadmap. But we do need to take that time to expand that to where we can have even better better modeling. Beyond the computer vision piece, though, I think what's a really exciting thing that we're working on right now is really trying to generalize our scope generation model. Right now, it's very tuned for our first customers, which are roofing and siding companies. But I think that there's a world and specifically residential roofing and siding companies that itself has a really nice TAM, and it's a great starting point for a lot of reasons. But if you really think about it, there's no difference between what we're doing here versus for commercial or for even other areas of construction. You have a bunch of site photography and documentation, and you have a goal of building an estimate that somebody is going to buy. So in the case of our current customers, that buyer happens to be an insurance company most of the time, but it could be a large government contract. It could be anything. So either way, like it's a big part of construction. It's actually most of construction time is people aligning ahead of time on what needs to be done, and ultimately like building a reasoning agent that can much more generically work for all types of construction, or at least for a much wider set of construction is kind of where we're going. So that's kind of the idea.
Great. Yeah, thanks for sharing, Rob. And we're excited to see you go there into those new spaces. It seems like a great opportunity. So I wanted to take a chance just to talk through what we're thinking of the future of visual AI specifically in kind of this construction space. Outside of LandingLens, which we're innovating on every day, adding new models to adding new features and functionality. I did mention at the beginning of our presentation that we're also looking at some other areas like agentic AI. And one of the products that we released recently is called agentic object detection, which is really, you can think of it as a single shot object detection model that's prompt based. So you can talk to a model and ask it to find things within an image based on your prompt, and it'll take the various characteristics that you describe and use that to do this kind of out of the box object detection. So we're pretty excited about it. It has some really good results already today. You can go on our website and try it out for free. But specifically in the construction space, like the example that we're seeing here, you can do something like, let's say you're monitoring a construction site, for example. You could ask the model to find all the people who aren't wearing their PPE or aren't wearing their helmets, right? And the model is going to be able to go through and detect those with a single shot without you needing to train anything, which is pretty cool. And we also see this as a potential process step in addition to the LandingLens workflow that we showed earlier, where you could kind of use this agentic object detection as a first pass to label data that then gets fed into a model that further fine tunes and gets even better at doing that particular task. I think there's a lot of potential applications for this, but we're really excited about it. So wanted to share it here as well. And then if we go to the next slide, there's another topic on the agentic space. And this is agentic document extraction. Again, another product that we recently announced. And you can think of this kind of the same thing. It's an agentic approach to analyzing documents, but really with a visual focus. Again, we're a vision-based company. So a lot of the document tools out there today really are based on language models, and they're very text-centric. So they're looking to analyze text within PDFs. And with this agentic document extraction with a visual focus, we're now able to really understand documents that are a little bit more complex and more than just text data. So let's talk about charts, figures, tables, images, anything within those documents. They all kind of contribute to the story that the document is trying to tell. And the agentic tool allows us to really understand that document better. And it's really cool. You can go to our website and check it out, but essentially you can drop in a PDF and talk to your document like you would with like ChatGPT, for example. But except you're going to be analyzing this document that has rich visual data as well. So we see this as a potential application in the construction space. We just heard XBuild and Rob talk about how they're actually generating these types of documents, right? And you can imagine there's a scenario where someone else wants to actually analyze these documents, right? So that there's a space where this kind of document extraction could be used. So we're really excited to see where our customers and users start to apply this, but another area that we think is going to impact the construction space in general. With that, I think we can jump to the conclusion slide. So yeah, I think just as a recap, we went through a quick introduction of what XBuild is doing, what LandingLens is actually doing, how XBuild is using LandingLens to automate this bid process, and the exciting results that they're getting to really yeah, scale their visual AI use cases and get a lot of benefit out of it, like reducing the time to generate these reports. And we're really excited about where this space is going and where XBuild is going, and seeing what we can do with them as they expand as a company. So, Rob, thanks again for joining. Really do appreciate it. And now I think we can hop to the Q&A section. Oh, we actually have one more slide here. Is this Grace? Do you want to cover this?
Yeah, sounds good. Thank you, Queen and Rob, for the informative session. So we will head to the Q&A after this. So if you have any question, I see already people start to ask the question. Feel free to use the Q&A feature on Zoom to ask your question. And also, we also offer free consulting with our visual AI specialist. So if you want to utilize our free consultation, please feel free to schedule a call. So we love to understand your use case and see how we can support. With that, I'll move to our Q&A. Our first question is, what are the common challenges encountered when adopting AI in construction? How does XBuild and XBuild solution address them?
So for me, I think, and I kind of touched on this a little earlier, I think part of the challenge is that there's a couple. One is that the actual quality of the images and the orientations, this isn't manufacturing where you can have like a static camera always looking down at a conveyor belt and it's always the same framed up kind of shot. This is people that are, half risking their lives standing on a roof at a weird angle, taking a shot of something that maybe to them makes sense, or maybe they don't even realize, but or maybe they don't realize that there's like other stuff in the frame that's not relevant to what they're doing. So I think that just the quality and the orientation of the images is a big challenge. And sometimes they come from drones too, which is really nice. Well, even in that case, it can be tough because then it's really far away. But so that's a big challenge. And the other big challenge is that even if you did have really, really consistent kind of photography quality, just even the components themselves can be pretty subtly different. Even in that one where it was not confident about whether or not there's a roof vent there, if you remember maybe 10 minutes ago, sorry, a ridge vent. I also was not confident about that because actually a ridge vent you can't see from that angle. You can only see it from the side because there's like the roof comes up like this. There's ridge cap shingles over it, but then under those shingles there might be a gap, and in that gap you can maybe see ventilation. So it's interesting that in that case I think the model was pretty good in that it was not confident in because it doesn't know. So anyways, that I think there's a lot of subtlety in what we're trying to detect. And then that subtlety ends up resulting in potentially erroneous scope line items being written. Now, the good news is even if there is an error, the customer can still say, hey, that's wrong. We can just pretty instantly, or at least very quickly revise that for them, but we don't want to have to do that.
Thank you. Can you wanted to add something?
Yeah, no, I was just I think they're good points, and on the image quality piece, yeah, one of the things that we've considered in the past is actually running separate models to actually give feedback on the images that the consumers are taking, or the consumers of the app are taking, right? So they take an image and maybe it tells them like, oh, this is too blurry or the angle's bad, right? So it's another thing to consider. But yeah, it's one of the challenges with these kind of applications where people are taking images and you have no control over how they're taking them, right? uh,
Yeah.
and then yeah, the subtleties piece definitely resonates. Um, Grace, did we have another question?
Yeah, another question related to video. So how customers' video get labeled and how
Hmm.
influencer run on video frames?
Yeah, maybe I can take that one. So a lot of applications that are being tackled in LandingLens are video applications. I think you're on the right track here. You say frames, so we're typically inferencing based on a particular frame rate in these videos, right? Um, we have a tool, it doesn't live within LandingLens per se, but we have a tool that we provide to our customers to essentially parse the videos and pull in the relevant frames to LandingLens. I mentioned our Edge application before called Landing Edge. It actually has functionality to take a video input and send specific frames back to LandingLens, and then you can run through that labeling process as if they're images in LandingLens and deploy that model. And then same on the deployment side, you would basically run on a frame rate that you choose on that video, right? So definitely possible. A lot of video applications that are being tackled in LandingLens today.
And do you plan to leverage area images from satellite or Google to identify roof needing replacements? I think it can be also general questions. What are type of image format support for the solutions?
Yeah, so I think if the question is about identifying customers, like homeowners that might need a new roof, I would say no, because our customer is the contractor, so that's kind of on them to find their own customers, their own end users. Because the homeowners have, you know, they're not our customer, they don't even necessarily know who we are. But if it's more about would satellite or aerial imagery that's available via like Google or Maxar or like 42 or something like that, like if those could be used in a project, the answer would be yes. We're not currently doing that, but I think that one thing, so like one example of where that could be really helpful is so like there's times where like if the user, sorry, if the contractor is taking photos by hand, they're all pretty up close. Like no photo of the roof is more than like, 5 or 6 feet away. But you can take an angled overview shot, but it is nice to just see the overall thing because then it's easier to count the number of like certain types of events. Now it's a lot farther away, so you don't know what types of events they are, but you can kind of use an ensemble of like your close-ups plus the top thing to actually have a better understanding of what's going on when writing the scope. So in that sense, we will be doing that.
Interesting. Yeah, and I wonder if that would become more needed as you move into kind of the commercial type buildings, right? That are larger and
Very possible.
yeah,
Yeah.
interesting.
I think one more questions. I think you guys already cover, but any best practices for the image acquisition for the better model performance for the training?
Sorry, I didn't get that one.
Best practice for the image acquisition for model training?
I can take it from the
Oh,
landing
yeah.
AI side. But Rob, welcome your inputs too. Yeah, I think the like the highest level rule that we tell our users is you need to have enough information in the image that a person looking at that image can make the judgment that you want the model to make, right? Um, and that pretty much is like the only rule you need to follow. Because if there's enough visual information in there for a person to see it, that means they can label it. That means the model can learn it, right? Um, if you want to get more granular than that, one of the common questions is like, oh, how much resolution do we need for an image? The rule of thumb there is that generally you want 10 pixels across the smallest feature that you want to capture, that you want the model to be able to detect. So you can kind of backtrack from there based on your smallest feature, how and like how the area that you're covering with your image, how big or how high the resolution needs to be to cover that. But really, I think what it comes down to is just being able to see it and make the judgment yourself on these images. But I don't know, Rob, if you want to add anything based on, I know you probably see a higher variety of images than we do with this.
No, I mean, I think that that's exactly it. I think it needs to be clear to a human, otherwise it can't be clear to a robot.
Right, right.
Oh, good. Thank you both. To learn more about Landing AI and XBuild, please visit our website and stay tuned for our upcoming event. With that, we can wrap up our session today. Thank you, Rob and Queen, for leading session today, and thank you everyone joining. There are one more question before. So so before wrap up, can you explain a little bit more about deployment on cloud side after the model has been trained in terms of a step-by-step process and related cost?
Yeah.
To say really quickly from our
Yep.
side, and then maybe when you might have some more details is, so I mean, for us, like when was showing the internal dashboard of training sets, so like literally it's that easy. So in that particular event model, I've like 2,000 or 3,000 images that we labeled. And once you press the button and are satisfied with its results of how well it performs against the validation set, LandingLens itself hosts the model, and there's just an API endpoint then that we call. So our backend system at XBuild, then just once we get an image that needs to get labeled, we have a queue, and then it runs through that by just calling the API, which will take not that long to then give us a response back. We have a series of API calls because, like I said, we first say, hey, what like category is this? Oh, it's roof. Great. Now let's like call some of these specific roofing agents. But either way, we can just handle that through API calls. They host it. I think Quinn was saying that there's also options to self-host, but we are not doing that.
Yep. Yeah. So I'm going to share my screen again really quick. So these are all the different models that were trained, right? If we want to deploy a model to a cloud endpoint, it is, like Rob said, quite simple. You click the deploy button next to the model. You'll have the option of either deploying to the cloud endpoint, which is done automatically by LandingLens. You can see below here, these are the different cloud endpoints that were already created. So like I could choose to create a new one. I'm not going to do this because I don't want to mess with their project, but you can create a new endpoint, and then it will take that model and basically run it on this cloud endpoint. And once that's done, you would be able to come to this page here, and basically you could use this following API command to send images to that cloud endpoint, and you would get predictions back in a JSON response, right? And I think the second part of that question was around the cost associated with it. So I can talk a little bit about that. You'll see, like when I hover over this training button, for example, it says this training run will cost you 1,087 credits, right? So we have this kind of, you can think of credits as the currency in LandingLens, where you use credits to train models, but you would also use credits to run inference in the cloud. So in this project, for example, as you're sending images to the cloud endpoint, we can see here for this particular model and this particular setup, it burns 4.5 or 5, roughly 5 credits per image processed, right? So the amount of credits used depends on kind of the pre-processing for the model. So like the ultimate size of the image that's being sent through the model endpoint, the model architecture, and then some of the training parameters. But it can range anywhere from, half a credit per image to 5-10 credits per image, depending on the training parameters here. Credits are pretty cheap in LandingLens. If you're interested in learning a bit more, I'm happy to hop on a separate call. But that's kind of how the commercial model works with LandingLens. There's a base subscription, and then there's credits that you purchase on top of that to actually cover the compute costs that you incur as you're using the platform.
Thank you, Quinn.
Mhm.
All right, with that, we can wrap up our session today. Thank you again, everyone joining session today. Look forward to connect with you in the future. Thank you.
Thanks, everyone.
Thank you.
Thanks, Rob.